Assalamualaikum warahmatullahi wabarakatuh and a very good morning everyone. So today we continue our lesson on digital electronics, chapter 7, latches and flip-flops. So today is the last part of chapter 7, which is mainly related to the flip-flops. So at the end of today's lesson, you are expected to know how to implement the flip-flop in digital circuit and how to design the flip-flop circuit inside the digital circuit. So without further ado, let's continue. So the first part of today's lesson, I will explain to you the introduction of flip-flops. So flip-flop are actually asynchronous bistable devices. So in the term of bistable devices, you already know in the previous lesson where latches is also a bistable devices. So the term synchronous means that the output changes state only at a specified point on the triggering input called the clock or CLK. So the main difference between the flip-flop and latches is the flip-flops is synchronous. So it means that the output changes only at specific time. But the latches, the possibility of output to change is at all time. Okay, so that is the difference between flip-flops and also latch. So this clock is designated as a control input C, which is in latches, we are using the control input C or enable. That is, changes in the output occur in synchronization with the clock. So there are several types of flip-flops. The first is the D flip-flops. The second type is the JK flip-flops. And the last type is the T flip-flops. So today we will learn all these three types of flip-flops. So next is the term edge trigger. So an edge trigger flip-flops change state either at the positive edge, rising edge, or negative edge, which is the falling edge of the clock pulse. So it is sensitive to its input only at this transition of the clock. So I've been mentioned to you in the previous slide that flip-flop is actually a synchronous device. So it means that the output changes only take place at specific time. So what is the time? So the time the flip-flops output changes is at the rising edge or at the falling edge on the clock signal. So the clock inputs of flip-flops are symbolized by a triangle in logic symbols. So later on you will see the the logic diagram of the flip-flop. So you see a triangle symbol. So it symbolizes a clock. So positive edge triggered, no bubble at clock input. And negative edge triggered has a bubble at clock input. So you see here, this is the example of the logic block of the positive edge triggered device. So you see the triangle here. So it symbolizes clock. So if you see the flip-flop that doesn't have any bubble at the clock input, so it means that it is positive edge or rising edge triggered. Okay, and then if the flip-flop block has a triangle and also a bubble at the clock input, it is negative edge triggered device. So it is falling edge and it has a bubble. So in this diagram, it means that the output of the flip-flop will be changed at each rising edge for positive edge triggered device, and the output of flip-flop will change at the falling edge, only at the falling edge for negative edge triggered device. So you must understand the term of edge trigger. So it is triggered only at the edge, either rising edge or falling edge. Okay, next I will show you the first type of flip-flop, which is D flip-flop. So D flip-flop is useful when a single data bit, 0 or 1, to be stored. So if you wanted to store the data which is 1 bit, 1 or 0, we can use D flip-flop. So it works almost the same as the D latch. So you still remember, right, what is the function and how to operate the D latch. So later on, I will show you what are the differences between D flip-flop and D latch. So when a clock pulse arrives, the input is transferred to the input. Only when a clock pulse arrives, the output will see what is the current input. Okay, the D flip-flop can be either positive age or negative age trigger. So if you wanted to know whether it is positive or negative age triggered, you can just observe from the logic circuit inside the question. So the positive age trigger D flip-flop, the input only valid or seen during the clock rising age. So as I've been showed to you in the previous slide, for positive age triggered, it is the output can be changed only at the rising age, and for negative age triggered, the output can be changed at the falling age. So this is the logic symbol of positive age triggered D flip-flop. So for positive age triggered D flip-flop, it has two inputs, which are D and also active high clock, because it doesn't have any bubble here. That's why it is called positive age. And then, as usual, it has a total of two outputs, which is Q and also Q bar. So this is the characteristic table of positive age triggered D flip-flop. So for D flip-flop, if the clock is at 0, it doesn't matter, if the clock signal is at 0 or 1, it doesn't matter what is the value of D, because the output will not change. So this is where the D flip-flop store data. Okay, and then you see here, when the clock is at the rising age and when D signal is equals to 0, the Q next is equals to 0. And when at the rising age, when the D signals is equals to 1, the Q next will equals to 1. So when Q next is equals to 0, it means that it is in reset mode. And when Q next is equals to 1, the flip-flop is inside the set mode. Okay, so I will show you the example of the waveform which are formed inside the D flip-flop. So draw the output waveform of the positive age triggered and negative age triggered of the D flip-flop. So this question asks you to draw the two types of waveform which are generated by the positive age flip-flop and also the negative age flip-flop. So first, I will show you how to draw the positive age flip-flop first. Okay, so the first thing is we need to observe the input signal, which are the clock and also the D. So you show here that the clock is 0 and the D is 0. So the initial output of Q positive and Q negative will become 0. Okay, so next we see that at the rising age of each clock signal, this is the rising age. Okay, and then you observe that the input D is equals to 0. So the positive age flip-flop will just follow the D signal. When D is equals to 0, the output will equals to 0. So this state will remains until it reach the next state of rising age. Okay, so this is the next rising age of the clock. So when we arrive at the next rising age of the clock, we observe the input D. So input D right now is equals to 0. So it will still maintains the value of 0 until it reach the next rising age. So at the next rising age, you see that the input D is equals to 1. So the output of Q will follow the input of D. So it will become 1 until it arrives at the next rising age. And then you see here that the input D is equals to 0. So the output Q will follow the input D, it will become 0. And then for the next rising age, the input D is equals to 1. Therefore, the output Q will follow the input D, it will become 1. And on the last rising age, you see here, the input D is equals to 1 and the output will equals to 1. Okay, next I will show you the negative age flip-flop, where the output will be changes when the falling edge is generated. So this is the falling edge, which is the signals that comes from 1 to 0. Okay, at the the first falling edge, the the value of D is equals to 0. So the negative flip-flop will just follow the value of D. So it will become 0. So next, at the next falling edge, you see here the value of D is equals to 1, so it just follow the value of D. And then on the next falling edge, the value of D is equals to 0, so it will become 0. So on the next falling edge, the value of D is equals to 1, so the output will become 1. And at the next falling edge, the output D is still become 1, so the output Q will become 1. And at the final falling edge, the input D is equals to 1, and the output of Q on negative flip-flop will become 1. Okay, so you must aware that the type of flip-flop, either it is negative or it is positive edge triggered. So if it is positive edge triggered, you observe the rising edge, and if it is negative edge triggered, you must observe the falling edge. Okay, now I will show you the comparison between the D latch and D flip-flop. So this is the comparison between D latch and D flip-flop, where this block is the D latch and the other block is the positive edge trigger D flip-flop and negative edge trigger D flip-flop. So in this example, we have two inputs, which are D and also clock. And for D latch, as we all know, D latch has two inputs, which are D and also enable pin. So the enable pin in this example is connected with the clock signal. And you see here the differences between the positive edge trigger and negative edge trigger of flip-flop is differentiated by the bubble here, which is directly connected to the clock. So now let's take a look at the output generated from the D latch and also D flip-flops. So as you all know, the output changes on the D latch is being conducted at each and every time, where the output of flip-flop is only changed when it is triggered by the either it is positive edge trigger or negative edge triggered. So this is the output that comes from the D latch. So you see here, if the input of the enable pin is 0, there are no changes on the output. And then if the input at the enable pin is equals to 1, the output will follow the input. So in this example, the input is D, and then the output is QA for D latch. So when the enable pin is set to 1, the output will follow whatever is the input that goes to the D pin. Therefore, the pattern of the output is similar with the input. And when it goes through the next stage where the enable pin is set to 0, the previous output will retains. So the the value of 0 will retains until it reach the value of 1. So when we set the value of 1 in enable pin of D latch, the output will follow the input signals. Okay, so the shape is the same as the signal D. And then it then set to 0 again, so the previous output will constantly the same. So it will retains throughout the waveform. So next, let's take a look at the positive edge trigger D flip-flop. So previously I've been explained to you when exactly the positive edge trigger D flip-flop will change its output. So it will change its output at the the rising edge of the signals. So at the first rising edge, you see here the D signal is equals to 1. So it means that at positive D flip-flop, the output will become 1. And then the output will constantly become 1 until it reach the next stage of rising edge, which is from 0 to 1. Okay, so at the next rising edge, you see here, the input D is equals to 0. Therefore, the output for positive edge D flip-flop will become 0. and then it will retains until it meets again the next rising edge. Okay, so lastly, we'll take a look at the negative D flip-flop output. So for negative H trigger D flip-flop, the output is triggered by observing the falling edge. So the first falling edge is here. So at the first falling edge, you see here, the input D is equals to 0. So as the initial value of the output is 0, so it will retains the value of 0 until it meets again at the next falling edge, which is here. So this is next falling edge, which is the what they call the input of 1 to 0, the falling edge, and then we observing the input D, which is equals to 1. Therefore, the next output of negative H trigger D flip-flop will become 1 because the input D is 1. So you see here, there are the example of the comparison between the output generated by D latch, positive H trigger D flip-flop, and negative H trigger D flip-flop. So you must know what are the differences, and you must carefully observe at the block diagram representations of each latch and also flip-flop so that you will not be confused. Okay, so next I will show you the next type of flip-flops, which are T flip-flop. So what is actually T flip-flop? So T, which represent toggle, flip-flop has two inputs, which are a clock and a T input. Okay, so when T is set to 0, a clock pulses have no effect on the output. But when T is 1, when a clock pulse arrives, the output will toggle. So this is the logic symbol of positive H trigger T flip-flop. So it has a total of two inputs, which are toggle and also clock, and it has two outputs, which are Q and Q bar. So this is the characteristic table of positive H triggered T flip-flop. So there are minor changes or minor difference between T flip-flop and D flip-flop. So the similarity between D and T flip-flop is when the clock is at 0 or 1 signals, it doesn't matter what is the input T because the output will not change. But at the rising edge of clock for positive H triggered, when T is equals to 0, the output will not change. But if at the rising edge, if the input T is equals to 1, the output will toggle. Okay, so for example, if the previous input is equals to 1, the next input will equal to 0. Or if the previous input is equals to 0, the next output will equals to 1. So it will toggle the output. Okay, so this is the example, which is you need to draw the output waveform of the positive H trigger of the T flip-flop. Okay, for this example, it already mentioned to you that it is the positive H triggered. So you need to observe at the rising edge of the clock. So you see here, at the first rising edge, the what we call the input T is equals to 0. So the what we call the output Q will equals to 0 because there is no changes in the T flip-flop. So we'll proceed to the next rising edge, which is here. So at the next rising edge, the input T is still equals to 0. So there is still no changes at the output Q. Therefore, the what they call output will return to 0. So when we achieve at the next stage of the rising edge, which is here, so you see the input T is equals to 1. So the output will toggles. So as the previous output is equals to 0, so the next output will toggles and it will become 1. Okay, at the next stage of the rising edge, you see here, the input of T is equals to 0. Therefore, the output Q will retains because there is no change at the output. Okay, and then you see here, at the next rising edge stage, you see here the input T is equals to 1. Therefore, the output Q will toggles because the previous value of the output is 1, it will toggles into 0. Okay, and then at the last stage of the rising edge of this example, you see here the input T is set to 1, so the output must toggle. So because the previous value of a Q is equals to 0, so it must toggle to the value of 1. So this is how the T flip-flop works when if the positive edge triggered T flip-flop, when the rising edge has been detected, we observe the value of T. So if T is equals to 0, there are no changes at the output. And if T is equals to 1, the output will toggle. Okay? Next, I will show you the next type of flip-flop, which is a JK flip-flop. So, JK flip-flop is versatile and it is widely used type of flip-flop. So actually, a JK flip-flop acts as the basic circuit of another components in digital electronics. So in the later chapter, you will see how JK flip-flop is being used to build another component in digital electronics. So JK flip-flop is identical to JK latch. So we already learned about JK latch in the previous chapter, where the output is toggled or inverted when JK is set to be 1, 1. But the input is changes during a clock edge. So the main difference between JK latch and also JK flip-flop is the changes of the output. So for JK latch, the output changes is possible at all times. But for JK flip-flop, the output changes only possible at each clock edge. So it is depending on the type of JK flip-flop, which is positive triggered or negative triggered. Okay, as usual, for positive triggered, the output will be changed during the rising edge. And for negative triggered, the output will be changed during the falling edge. So this is the logic symbol of positive edge triggered JK flip-flop. So for positive edge triggered JK flip-flop, it has a total of 3 inputs, which are J, K, and also input clock. So as usual, it has a total of 2 outputs, which are Q and Q bar. So this is the characteristic table of positive edge triggered JK flip-flop. So as I have been mentioned before, if the clock signal is constantly become 0 and 1, it doesn't matter what is the input of J and K, because the output will not change. So the output of JK flip-flop positive edge trigger will only change during the rising edge. So for rising edge, if J is equals to 0 and K is equals to 0, there are no change at the output. So it means that the JK flip-flop is in data storing mode. So for the next row, it shows that on the rising edge, if J is set to 0 and K is set to 1, the Q next will become 0, and it is mean that the JK flip-flop is in reset mode. And if it is at the rising edge and the value of J is equals to 1 and the value of K is equals to 0, so it means that the JK flip-flop is in set mode, and the Q next will become 1. And if it is at the rising edge and the value of J is equals to 1 and the value of K is also equals to 1, the output will toggle. For example, if the current output is 0, the next output will become 1. And if the previous output is 1, the next output will become 0. So next, I will show you one example. So draw the output waveform of the positive edge triggered of the JK flip-flop. So this question already mentioned to you that the type of JK flip-flop is the positive edge. So you can just observe the rising edge of the clock of each cycle. Okay, so for the initial value of the J and K and Q, you see here J is 0, K is 0, and Q is set to be 0. And then we observe the first a rising edge of the clock. Okay, when the first rising edge, the value of J is equals to 1 and the value of K is equals to 0. So it means that the flip-flop is in set mode. So the Q will become 1. So we proceed to the next rising edge. So we observe the next rising edge, the value of j is equals to 0 and the value of k is equals to 1. So it means that the flip-flop is in reset mode. So the output will become 0. So next we observe the next cycle of the rising edge. We see here at the rising edge the value of j is equals to 0 and the value of k is equals to 1. So the latch is still in reset mode. So the value doesn't change. And then we observe the next rising edge. So we see here the value of j is equals to 1 and the value of k is equals to 1. So it means that the output must toggle. So in order for us to decide what is the next value, we see the previous value of the output. So the previous value of the output is 0. So when it is toggled, it will become 1. And then it will retain until it achieves the next rising, what they call rising edge. Okay. So at the next rising edge, the value of j is equals to 1 and the value of k is also equals to 1. So it will toggle again. So the output will toggle again. So we observe at the previous output. So right now the previous output is 1. So the output will toggle to 0. Okay. So at the final stage of the waveform, it shows that at the final rising edge, the input j is equals to 1 and input k is equals to 1. So it means that the output will toggle again. So the previous output is 0. So it will toggle to a value of 1. So this is how the JK flip-flop works, where the functions and how it is worked is similar to the JK latch, but the changes of the output only occurs at the rising edge for positive edge triggered, and for negative edge triggered, the output, what we call changes, occurs at the falling edge. Okay. So next, we have seen 3 types of flip-flops. So these flip-flops can be implemented using JK flip-flop. So previously, I already shown you 3 types of flip-flops, which are D flip-flop, T flip-flop, and also JK flip-flop. So actually, we can design D and T flip-flop by using a JK flip-flop. So how to design it? Let's continue. So to implement a D flip-flop, an inverter is placed between J and K inputs. Okay, so because D flip-flop only has 2 inputs, which are D and also clock, and JK flip-flop has 3 inputs, which are J, K, and also a clock. So in order for us to implement a D flip-flop, we need to connect the D input each into J and the second one into K. But for for able to operate the D flip-flop, we need to add some inverter. So we need to add one inverter at K before it is entering the K input. So it is you can just simply design the D flip-flop by using JK flip-flop. So the next type is to implement a T flip-flop. You can just connect both inputs of J and K all together. So to design a T flip-flop from the JK flip-flop, you can just connect the input T into both input of J and K. So you can just simply design the D and T flip-flop by using one JK flip-flop. So from here, you already can see that JK flip-flops can be operated as other types of flip-flops. Next, I will show to you the asynchronous flip-flop. So what is actually asynchronous flip-flop? So previously, we have seen synchronous flip-flops such as D, T, and JK flip-flop. But I haven't explained to you what is synchronous and asynchronous flip-flop yet. So a synchronous flip-flop is defined as the input transferred on the triggered edge of the clock. So data transferred synchronously with the clock. So from this definition, we can conclude that a synchronous flip-flop is a flip-flop where the input is being transferred synchronously with the clock. So it means that the input only can be transferred during the positive edge or negative edge of the clock. So the input transferring session will be solely depends on the edge triggered inside the clock. So in asynchronous flip-flop, the input effect flip-flop state independent of the clock. So basically, for a synchronous flip-flop, the input transfer to the flip-flop, it doesn't depend on the input clock. Okay, so it doesn't matter what is the clock input. The output will change ultimately if there is the required input used to change the output. Okay, so the asynchronous flip-flop normally labeled by preset PRE bar, direct set and clear CLR bar, and also direct reset. So this is actually the logic diagram of the asynchronous flip-flop. So for asynchronous flip-flop, it has a usual input which are J, K, and also clock. But it has two additional input which are PRE bar and also CLR bar. So as usual, it has two output which are Q and Q bar. So in order for you to know what is the mode of the asynchronous flip-flop, you can see from this table. So this table shows that the asynchronous flip-flop can be triggered by using two different modes, either asynchronous and also synchronous, based on the input given to the asynchronous flip-flop. So it can go back and forth, asynchronous, synchronous, asynchronous, and also synchronous mode. Okay, so you see here from this table, we have two inputs that need to be observed before we proceed to operate the asynchronous flip-flop, which are PRE bar and also the CLR bar. So if PRE bar is set to 0 and CLR bar is set to 1, the flip-flop will go to the set mode. So it means that it is in asynchronous mode because the output will automatically become, the Q will automatically become 1. So it doesn't matter what is the clock condition. So next is when PRE bar is set to 1 and CLR bar is set to 0, so the asynchronous flip-flop will go into reset state. So it is in asynchronous mode because it will automatically makes the output of Q become 0. It doesn't matter what is the condition of the clock input. So next, if the PRE bar is set to 1 and CLR bar is also set to 1, so the asynchronous flip-flop will enter a usual JK flip-flop. So it is entering the synchronous mode where the output is depending on the input clock. So it will observe the rising or the falling edge of the clock signal based on the type of the JK flip-flop. Either it is negative triggered or positive triggered. So this is the example of the characteristic table for asynchronous JK flip-flop. So previously I have already explained to you what will happen if we give the input of preset bar and also CLR bar. So if we give both inputs into PRE bar equals to 1 and CLR bar equals to 1, so it will enter the usual JK flip-flop mode. So if we give the inputs of PRE bar equals to 0 and CLR bar equals to 1, it will make the Q output automatically become 1 because it will make the flip-flop to become set. So if we give PRE bar into 1 input and CLR bar to 0, so it will make Q output to become 0. Okay, so it will make the output to become reset. Okay, so this is the example of the asynchronous flip-flop. So the example given as, draw the output waveform for asynchronous JK flip-flop given an input timing diagram as below. So the example asks you to draw the output waveform which is Q. So it has given the CLK, which is the clock signal, PRE bar input, CLR bar input, and they want you to draw the output Q. So here you see here the example gives you the condition of J and K in each clock pulse. Okay, so first we need to observe the initial condition. So the initial condition is given as PRE bar is set to 1 and CLR bar is set to 1. So it is entering the usual JK flip-flop. So at this condition, it needs to observe where is the the rising edge of the clock. So at this condition, it still doesn't meet any rising edge. So and then the pre-bar goes to the 0. So the pre-bar has been set to 0 and the CLR bar is set to 1. So right now, the flip-flop has entering the asynchronous mode, where when PRE bar is equals to 0 and CLR bar is equals to 1, it will makes the flip-flop to become set. So when the flip-flop is becoming set, the Q output will automatically become 1. So it doesn't matter what is the clock input signals. Okay, so it will change the output of flip-flop into set mode until you see here the changes of the pre-bar input is set to 1 and also the CLR bar is set to 1 again. So it means that the flip-flop is entering the basic JK flip-flop again. Okay, so pre-bar is set to 1 and CLR bar is set to 1. So the flip-flop state will toggle if it meets the rising edge. Okay, because in this example we are considering the positive edge triggered. So after it's set to 1, so the flip-flop will find where is the positive edge triggered. So positive edge triggered occurs here. So it will observe the condition of the pre-bar and CLR bar. So it is still 1. So it means that it's still entering the JK flip-flop mode. So it will makes the output to toggle. Okay, so the to toggle and the the input of pre-bar and CLR bar in the next rising edge is still is still maintaining to be 1. So it means that it enters the JK flip-flop mode. So it will toggle the output again. So until it reach the next state of the rising edge, so it will observe the pre-bar and also CLR bar. So it is still set to 1 1. So it will still enter the JK flip-flop mode again. So it will toggle the output. And the 7th clock pulse, it is still set to 1 1. So it will enter the JK flip-flop mode, synchronous mode. So it will toggle the output again. And then suddenly, before the clock achieves the 8th pulse, the CLR bar input has been set to 0. So it makes the asynchronous flip-flop to enter asynchronous mode, where when PRE bar is set to 1 and CLR bar is set to 0, it will become reset. So the output will automatically become 0. So it doesn't matter what is the input clock. Okay, until at the end of the a waveform. So it will maintain the output of 0 because the pre-bar and CLR bar is maintaining to be 1 and 0 until at the end of the waveform. So next is the IC, which is being used for the flip-flops. So the first IC that we will learn about 74x74 IC, which is actually a dual D flip-flop. So 74x74 contains two identical D flip-flops that are independent of each other, except it is sharing the similar power source, which are VCC and also the ground. So the flip-flop are positive edge triggered. So you need to remember that for this type of IC, both D flip-flops are positive edge triggered and have active low, asynchronous preset and clear output. So you see here, this is the IC connection diagram. So for this IC, we have two connection of the input, which are VCC and also the JND, which is the power supply. And then it has a total of two flip-flops. So this is the first D flip-flop and this is the second D flip-flop. So you see here, it has a total of 1, 2, 3, and 4. 4 different inputs. Okay, and 2 usual output Q and Q bar. So it means that if any of the flip-flop has the input of CLR bar and also the PR bar, so it means that the flip-flop is a synchronous flip-flop. So it can enter synchronous and asynchronous mode depending on the input given to the CLR and also PR bar. Okay, so similar to the second flip-flop, so the flip-flop of both are identical, so you can have two flip-flop in one IC. Okay, next we have flip-flop IC 74X76. So for this one, it is a dual JK flip-flop. So previously I've shown you dual D flip-flop, but this one is JK flip-flop. So 74X76 IC contains two identical JK flip-flops that are independent to each other. So except they are sharing the same power source, which is VCC and also ground. So the flip-flop are negative age triggered. So right now you need to remember the IC of 74X76 is negative age triggered JK flip-flops and have active low, asynchronous preset and clear output. So this is also the asynchronous flip-flop, which it can go back and forth in synchronous and asynchronous based on the input. So this is the IC connection diagram for 74X76 IC. So as usual, it has two different inputs. So for example, the annotation of 1 represent the flip-flop number 1 and annotation 2 represent the flip-flop number 2. And this is the power supply, VCC, and also the GND. Okay, so you can identify which part of the pins belongs to the first flip-flop and which part of the pins belong to the second flip-flop based on the annotation given to the number. Okay, 1 and 2. Okay, this is the final example in this chapter. So given input waveforms that are applied to one of the JK flip-flop in 74X76, so you must determine the 1Q output waveform. So you see here, the annotation 1 is given as the first flip-flop inside the IC 74X76. Okay, so for this IC, it is negative age triggered. Okay, so as usual, we in order for us to investigate the asynchronous flip-flops, so you must first see the initial condition. So you see the initial condition of J and K, and the preset is initially set to 0 and then it's set to 1. So it is entering the usual JK flip-flop. And then it will meet the falling edge because it is the negative triggered. So when we observe the falling edge, the input J is equals to 0 and the input K is equals to 1 because it is entering the JK flip-flop because the PRE bar and CLR bar is set to 1. So it will become 0 because it is in reset mode for JK flip-flops. And then we observe again the value of PRE bar and CLR bar. So in the next falling edge, the PRE bar and CLR bar is still set to 1. So it means that it will still enter the JK flip-flop mode. So it will operate as usual. So J and K is set to, both are set to 1. So it means that the output will toggle. Okay, so the output will toggle. So we observe the previous output, which is 0. So we toggle it into 1. And then we observe the PRE bar and CLR bar again on the next falling edge. So it's still set to 1. So it is still entering the basic JK flip-flop mode. So right now the value of J is equals to 1 and the value of K is equals to 0. So it means that the flip-flop is in set mode. So the value of 1 retains. Okay, and then we observe the PRE bar and CLR bar is still on 1 1. Okay, it's still set to 1 1 when the clock is entering on the next falling edge. So it means that it is still entering the JK flip-flop mode 1 0. So it will still retains the value of 1 because it is in set mode. But suddenly you see here the input CLR bar is suddenly set to 0 and the input PRE bar is retains. So it means that the output will automatically become 0. Okay, because it doesn't matter what is the clock input. So it will automatically enter the asynchronous mode. And when the PRE bar is set to 1 and CLR bar is set to 0, the flip-flop will enter the reset mode until it reach the falling edge again. Okay, so this state will retain until it reach the next falling edge. So this is where the next falling edge is happen. So at the next falling edge, we observe again the input of PRE bar and CLR bar. So at the input of PRE bar, we see here it is set to 1 1. So it will enter the basic JK flip-flop again. Okay, so the output will become 1 because in JK flip-flop, if J is equals to 1 and K is equals to 0, it is in set mode. So the Q will become 1. And then on the next falling edge, we observe the value of PRE bar and CLR bar. So it still retains to 1. So it will enter the basic JK. Okay, the JK is preset to 1 and also K is set to 1. So it will toggle. So 1 will become 0. Okay, and then we observe again on the next falling edge. So you see here it is still set to 0 1 1 for PRE bar and CLR bar. So for this one it is 0 because it is in reset mode. And then suddenly the PRE bar is set to 0. So it means that the asynchronous JK flip-flop entering the asynchronous mode, where it will change the output automatically to become 1 until it reach the next falling edge. Okay, so at the next falling edge, you see here the PRE bar and CLR bar is set to 1 1, so it will enter the JK flip-flop mode. So it will become 0 because it is in reset. And the next falling edge is still set on 1 1. So this time the J and K is both are equals to 0 0. So it is in what we call the data saving mode because the output will not change. And then the value of PRE bar and CLR bar is set to 1 1 again on the next falling edge. So you see here the input J and K is set to 0 0, so the output doesn't change. And at the end of the waveform, the last falling edge, the PRE bar and CLR bar is set to 1 1, so it is entering the basic JK flip-flop mode. And at the J and K input, we see here J is equals to 1 and K is equals to 0. So it means that it is on the set mode. So on the set mode, Q will become 1. So from this waveform, in order for you to answer this question, if you see the question is about drawing the output of waveform for a synchronous flip-flop, what you need to know is that first you need to observe the initial condition. And then you need to define what is the type of flip-flop, whether it is positive edge triggered or negative edge triggered. So for this example, it is negative edge triggered. So next we must observe what is the input at the negative edge triggered. Okay, at the first negative edge triggered. So when you get the time when the first negative edge triggered is happening, first you must observe the input of PRE bar and CLR bar, because you wanted to know what is the current mode of the asynchronous flip-flop, whether it is asynchronous or synchronous. And then you repeat the same procedure for each falling edge. Okay, so for the next falling edge, you observe the PRE bar and CLR bar first, and you define what is the mode, asynchronous or synchronous. If asynchronous, you will automatically get the output. And if it is synchronous, you need to observe the input of J and K, and then you will get the output. Okay, so this is how you can solve the problem of asynchronous flip-flop by using the flip-flop IC. So for flip-flop IC, you need to know the model of each IC, 74x74 or 74x76, and you need to remember either it is positive or negative age triggered. So that's all for today's class. Thank you.